Hello, everyone. My name is Dianwei from Shenghan University. I'm very glad to present my work. The topic of my present is a method of digital elevation model generation by data fusion of multi-device point cloud. This is an outline of my presentation. My paper will report to you from the following 5 parts, and the methodology section contains 3 parts. With the acceleration of urbanization, more citizens want to exercise with the nature environment. So, many urban greening projects were born. Until 2022, China has built more than 80,000 kilometers of urban greenways. However, there is a problem in the initial stage of greenway construction. The original topographic survey method is time-consuming, inefficient, and easy to delay the progress. In order to solve this problem, some scholars have proposed the method of data acquisition by using new equipment, which can improve the efficiency of measurement. Some other scholars have proposed innovative registration algorithms to improve the accuracy of data processing. However, few people have studied the multi-device collaboration and large-scale data fusion. Therefore, this study possesses a large-scale elevation data production method based on point cloud data collected by unmanned aerial vehicle and handheld device. This is the framework of my paper. First, the UAV collects the point cloud within the overall range, finds the parts that are not scanned after proceeding, then use the handheld device to conduct supplementary scanning. During the fusion stage, the complete point cloud is fused through roof and fine registration. Finally, the digital elevation model is generated by the complete point cloud. The following will be described in detail according to each part. This part mainly introduces the contents of data collection. Before everything starts, UAV should first pay attention to selecting an open and moderate place for takeoff. It's better not to have high-rise buildings and pylons, which will affect the control and communication between the UAV and the operator. In addition, planning the flight path also can effectively improve accuracy and set overlap rate. After obtaining the point cloud by UAV, proceeding this in software can get areas that have not been scanned. These areas will be supplemented by handheld device. In this process, it's necessary to focus on scanning certain areas by using specific routes. Now, we already have the source point cloud by handheld device and the target point cloud by UAV. Next, the registration stage is divided into 2 parts. First is roof registration. It refers to roof marching, where the transformation is completely unknown. And the main purpose of this is to provide better initial values for fine registration. As shown in right chart, by means of downsampling and feature extraction, the rigid transformation matrix is randomly selected to transform the coordinate system of the 2 point clouds. The above processes need to calculate the approximate rotation matrix R through iteration. Second is fine registration. We default that only rigid transformation exist, so the problem can be expressed as thinking the minimum value of the formula at the bottom. To solve this problem, we use initiative consist point algorithm. As shown in this table, the essence of ICP is to calculate the transformation relationship between two sides of point clouds by matching the nearest point, and transform the point cloud and calculate the error. Then, select the nearest point as the matching point again and solve the transformation relationship. Repeat above process until the error meets our requirements. According to the above description, ICP algorithm divides the registration into two problems: find the correct point and find the optimal transformation. First problem is to transform the initial point cloud by using parameters from initial to get a temporary transformed point cloud. Then, compare this point cloud with the target to find the nearest neighbor in source and target. The second problem is shown in these formulas by using SVD to calculate the R star and the T star. The full name of SVD is singular value decomposition, which is an algorithm that decomposes eigenvalues of matrices to get parameters. The elevation data is produced after registration. As shown in the process on the left, we will perform the secondary noise reduction at first. Then, due to the geographical conditions, there are some small areas that cannot be scanned. So, the linear interpolation method is used to fill the remaining areas. Finally, we convert the point cloud to grid data set and generate a digital elevation model and contours. This is a validation of this study. A grid land in Shenghan University is selected for the experiment. It covers an area about 6,316.29 square meters, and the height difference is about 10.82 meters. The UAV named DJI-M300, equipped with L1 laser scanning camera, is selected as the air equipment. The handheld device uses GeoSLAM backpack laser scanner. So the total weight of equipment is 20.37 kg, and the total experimental time is 33 meters. The results are shown in the figure on the right. The experimental results are compared and verified. As shown in first figure on left, the point cloud scanned by UAV is compared with the multi-device. It can be seen that the fused point cloud is more complete. And the second figure compares the contours with original data. It can be considered that the height is consistent. The figure on right compares the elevation data by only using UAV and multi-device. It can be seen that the former one has a large error. Therefore, the effectiveness of this study has been verified. Finally, this is summary and the future work. The method in this study not only makes up for the defects of incomplete scanning when only using UAV, but also slows the small connection range and short endurance time by only using handheld device. Furthermore, it improves the efficiency accuracy and reduce the burden of staff. However, there are still some deficiencies. For example, the ICP algorithm is easy to fall into local optimal solution, and some improved algorithm can be tried in the future. And the multi-device scanning still cannot cover all areas, so more advanced equipment can be considered. In addition, the station and the path planning of data collection by air and ground equipment can also be used to improve the collection accuracy. That's all of my presentation. If you have any questions, please write to me. Thank you for your listening.